Okay, so now we will try to write an efficient program to transfer these 3 bytes to new 3 locations. So initially the bytes are here and we want to transfer to new locations. We will start our program with org 0000H. Now what we will do, our 3 bytes are there. So our first number is at location 30H, second 8-bit number is at location 31H, and third number is at location 32H. So whatever number is there at 30H, that has to be transferred at location 40H. Whatever is there at 31H, that has to be transferred at 41H. And whatever 8-bit number is there at 32H, that has to be transferred at 42H. So this is the memory location of source data. This is the source and this is our destination. So here I will write one instruction, move R0, comma, hash. So in R0 register, I will store the memory location of my first source data. So our first data is at this address 30H. So this address I will load in R0 register. 30H. We have loaded in R0 register. So why I have loaded in R0 only, not in R3 or R5, and what is the intention to load this address in R0, that will be clear after some time. Now I will use another register R1. In R1 I will store the destination address of my first byte. So our first byte is at source address 30H. This we have stored in R0, and the destination memory location for the first byte is 40H. So that 40H we will load in R1 register. Now I will use another register. Now move R2, comma, hash. Now in R2 register I will load that number for how many bytes we want to transfer. That many byte we have to write in R2 register. Now since we want to transfer total 3 bytes, that's why we will write in R2 register 03H. If we want to transfer 5 bytes, then in this register we will write 05. So how many bytes we want to transfer, that we will write in R2 register. And basically our R2 register will act as counter. So what approach I will use to transfer this byte? What I will do? First I will transfer first byte from 30H to 40H. Then I will check whether I have transferred all the bytes. If I have not transferred, then I will transfer second byte to this location. After this again I will check whether I have transferred all the bytes. No. Then I will transfer third byte to this location. Then again I will check whether I have transferred all the bytes. So just for checking that whether we have completed our task or not, for that I am using this register R2. It acts as a counter. It will just verify whether we have completed our task or not. Since our task is to transfer 3 bytes from this location to new location, that's why I have used counter as 3. Now what I will do, I will bring the first number which is at address 30H in A register, in accumulator register, and for this I will use register indirect addressing mode. So if you remember, in case of register indirect addressing mode, the syntax is like this. This is our destination and this is our source. In the source we will use @RI. So here, so same way I will use this instruction, move A comma @R0. So what is the meaning of this instruction? Whatever is the content of R0, that will be the address. That will be the address. From that address, one 8-bit number will be moved in A register. So what is there in R0? In R0 we have already loaded 30H, which is the address of our first number. So we know that when we are using register indirect addressing mode, then we can use only R0 and R1 register. That's why intentionally I have loaded this 30 in R0. So here I cannot, because here I cannot use R2 to R7. Any of these registers I cannot use. That's why we can use here R0 or R1. Only 2 options are there. So I have used R0 here to store the address of our first byte. So now with this what will happen? First number. So in R0 we are having 30H. In R0 we are having 30H. So now with this instruction, the content stored at 30H will be moved in A. At 30H we are having A3. So A3 will be moved in A register. Now after this instruction I will write move @R1, A. Now what is the meaning of this instruction? Whatever is there in A register, that will be moved to internal RAM, and the address is defined by R1. The content of R1, we have already initialized this with 40H. That is the first address where our first byte will be stored. That since I knew that I am going to use this instruction, that's why already in R1 we have loaded 40H. So now with this in A, already we have A3, that will be moved at 40H. So this A3 will be moved at 40H. In this way, 1 byte has been transferred. Now after this, I will write instruction INC R0. So it will increase the value of R0 by 1. In R0, we already have 30H. So with INC R0, it will become 31H, which is the address of my second number. Then INC R1. So it will increase the content of R1 by 1. The content of R1 is 40H. So now it will become 41H. This is 41H, which is the destination address of my second byte. Now after this, I will use instruction short jump D, J and Z R2, comma back. This is one level and back is here. This. So now what this instruction will do? D, J and Z. Decrease jump not 0. Decrease the value of R2 by 1. If it is not 0, then jump to level back. back is this, then come to this place. So decrease the value of R2 by 1. If it is not 0, then go back to this place. So in R2, we are having 3. Since this R2 acts as a counter, that's why we have loaded in R2 total number of bytes which we want to transfer. So 3 bytes we want to transfer, that's why in R2 we are having 3. So with this instruction, R2 is decreased by 1. So R2 will become now 2. Now since it is not 0, that's why go to label back, jump to this place. And now execute this instruction, this instruction, this instruction, this instruction. After this again D, J and Z, decrease R2 by 1. If still it is not 0, again go back to the label. In this way, now our controller will be in this loop. Controller will execute these set of instruction continuously. And the moment value of R2 will become 0, this indicates that we have completed our task, or all the 3 bytes have been transferred. So once the value of R2 is 0, our task is completed. And if it is 0, then don't go to label back, don't jump, come out from the loop. So controller will come out from the loop and it will come to this place. So here we will write some instruction to stop the working of our controller because our work is completed. So here I will write SJMP and label is here. Label is here. So in this and in the last we will write AND. So one by one we will just see how these instructions are executed. So with the first instruction, R0 will become 30H. Move R0 comma hash 30. Move R1 comma hash 40. In R1 we are having 40H. Move R2 comma hash 03. In R2 we are having 03H. Now with this instruction, move A comma at the rate R0. In R0 we have 30H. So this 30H will be the address. From this address, the content of this address is A3. That will be moved in A register. So with this instruction, in A we have A3H. Now next instruction, move at the rate R1 comma A. So now content of A will be transferred to the memory location whose address is defined by R1. So R1 is having 40. So now the content of A will be moved to 40 address and content of A is A3. So now A3 will be moved to this address. So here we will have now A3H. After this, INC R0. R0 value will be increased by 1. So now this will become 31H. Then next instruction, INC R1. So value of R1 register will be increased by 1. So earlier it was 40H, now it will become 41H. Then D, J and Z R2. Decrease the value of R2 by 1. If it is not 0, then go to the label back. So now R2 is 03, it will be decreased by 1. So it will become now 02H. Now since R2 is not 0, that's why go back to label back. So program controller will come back to this. And here move A comma at the rate R0. So whatever is there in the RAM whose address is defined by R0 will be transferred to A. What is there in R0? R0 we have 31. So at 31 we have content CF. So this will be moved in A register. So now in A register in place of A3 we have now CF. Then next instruction, this move at the rate R1 comma A. So now the content of A will be transferred to the memory whose address is defined by R1. And in R1 we have 41. So content of A, which is CF, will be moved to 41 address. And 41 address is this. So here CF will be moved. After this, INC R0. R0 is increased by 1. So now R0 is now 31H. Now it is increased by 1, it will become 32H. INC R1. So R1 will be increased by 1. R1 we have 41H, now it will become 42H. D, J and Z R2. R2 is decreased by 1. If it is not 0, go to the level back. So R2, right now it is 02, it is decreased by 1. So it will become 01. So it will become 01. So it is not 0, so go back, not 0. This indicates that still our task is pending, right? That's why it is acting as a counter. So it is not 0, go back to level back. Again we will come to this. Then this instruction is again executed, move A comma at the rate R0. So in R0, whatever is the value of R0, that is the address. From that address, data will be moved to A register. So in R0 we have 32H. So at the 32H we have 29H data. So this data will be moved in A register. So in A register, now we have 29H. In A register we have 29H. Then this instruction will be executed, move at the rate R1 comma A. So whatever is there in A, that will be moved in RAM whose address is defined by R1. So in R1 we have 42H. So the content of A will be moved at 42H. In A we have 29H. So this will be moved at 42H. So here we have now 29H. After this INC R0. R0 will be increased by 1. From 32 it will become 33H. INC R1. R1 will be increased by 1. It will become 43H. Now D, J and Z R2. R2 is decreased by 1. So in R2, previously we were having 01. Now it will decrease by 1. So it will become 00. So now D, J and Z decrease, jump not 0. If R2 is not 0, then only you have to jump. But right now, due to the decrement of R2, it has become 0. Now if it is 0, then controller will not jump. It will come out from the loop and it will execute the next instruction written after D, J and Z. So program will come out and this instruction will be executed. So S jump here. Now controller will execute this instruction only. So in this way, the moment the value of R2, which is a counter, when it will become 0, this indicates that we have transferred all the 3 bytes and our controller will come out from the loop. So in this way we have transferred all the bytes. So in this program, I will write here the number of bytes for this program. Number of bytes for these instructions. So here move R0 comma hash 30H. So there is a 1 byte for move R0 opcode and 1 byte is there for this data. So this instruction is 2 byte instruction. Move R1, there is 1 byte for move R1 opcode and 1 byte is this particular data. That's why this is a 2 byte instruction. Move R2 comma hash 03H, again this is 2 byte instruction. Now move A comma at the rate R0. This instruction is 1 byte. Move at the rate R1 comma A. Again this instruction is 1 byte. INC R0 is 1 byte instruction. INC R1 is 1 byte instruction. D, J and Z R2, there is 1 byte for this particular instruction and 1 byte for the relative address. So this instruction is a 2 byte instruction. And S jump here, 1 byte for S jump and 1 byte for this relative address. So this is 2 byte address. So in total there are 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 bytes in this particular program. Now if we compare this with that program which we have written previously. So in that particular program, total number of bytes 3332. 11, and here it is 14 bytes. So it seems that when we are transferring 2 bytes, then this program is, when we are transferring 3 bytes, then this program seems to be efficient because it requires only 11 bytes for the program, whereas this program required 14 bytes. But you just think, if we are transferring 10 bytes by this approach, then we require 32 byte program. Because if the number of bytes are increasing, then for transferring each byte we require a 3 byte code. So if 10 byte program is 10 bytes we want to transfer, then for transferring 1 byte we require 3 byte instruction. To transfer 10 byte we require 30 byte instruction. In the last, for SJump we require 2 byte. That's why 32 byte program is there. Whereas in this case, if we want to transfer 10 bytes, then simply in our program, in this counter, in place of 03, we will write 0AH. 0A indicates 10. So now no need to change the program, only we have changed this byte. So again, this particular instruction is will remain 2 byte instruction. So we require, with the same program, you can transfer now 10 bytes, only we have changed this counter. If you want to transfer 100 bytes, then simply in this counter you can write what is the hexadecimal number for 100. So that number has to be loaded in R2. If you don't know what is the hexadecimal number for 100, so while writing your program in the MCU software, you can write in this way, 100D. This D indicates this is a decimal number. When you compile this program, then your assembler will automatically convert this 100 decimal into its equivalent hexadecimal. So that work will be done by controller automatically. So don't worry, simply write here 100D and it will be converted in hexadecimal number automatically. So if you want to transfer 100 byte, again our program number of byte in the program will remain same. It is 14 byte. So this we can say is a universal program which is used to transfer number of bytes. You can change the number of bytes, but there is no change in the number of bytes in the program. And only you have to change in your program code only at this point. You have to change the counter. Whereas if you want to transfer 10 bytes, then you have to write here 10 instructions. Move, destination source, move, destination source, move. 10 times you have to write. If you want to transfer 100 byte, then with this approach, first instruction you have to write to transfer first byte, then second byte, then third byte. Like this you have to write 100 instructions, 100 move instructions. So you have to again change your program at many places. But here you have to change your program only at this place, where you have to change the value of counter. That's all. So this is the efficient way to write your program. So as a programmer, you must try to write a program, an efficient program, which consume less number of byte and which is universal type, so that it can be utilized for transfer of 2 byte, transfer of 10 byte or transfer of 100 bytes, like that. So you must try to write the program which is efficient. Efficient means which consume less number of bytes, because the resources in the controller is limited. We are having limited code memory and we have to use only that code memory, right? And also, if the number of bytes in the program are less, then the program will be executed very fast as compared to a program which is having more number of bytes. So that we will see in other class. If the number of bytes in the program increases, then how it affects the execution time of particular program. So whatever we discussed, what one program we discussed, the efficient way to write a program for the transfer of 3 numbers. So same program we will now run in MCU 8051. So what we will do, this is the memory location, this here, this is the memory location 30. At this location we are having 00, this is the 31 location, this is the 32H location. So first we will load the data in these locations. So at 30H we will load A3. So we load here A3. Then the next location is 31. At this location we will load CF. And this location is 32H. At this location we will load 29. So these are our data right now at location 30H, 31H and 32H. We have to transfer these numbers. So whatever there at 30H, that is A3, this has to be transferred here. This location is 40 location. Here it is written 40H, so this location is 40. So A3 from this location it has to be transferred here. CF at 31 has to be transferred to 41, this is 41 location. Right now here it is 00. Then the 29 value which is at 32 address, it has to be transferred to 42H RAM location. This is the 42H RAM location. Currently here we have 00. So we will execute this program. Now move R0, #30H. So address of our first byte source address will be loaded in R0. So R0 right now it is 00. We will execute this. So now 30H has been stored in R0. Now the next instruction, move R1, 40H. So with this we will load the address of first byte destination, which is 40H in R1. So currently in R1 we are having 00. So we execute this. So now again we have here 40H. That is the first byte destination address is stored in R1. Now move R2, #03. This R2 register acts as a counter. Since we are transferring 3 bytes, that's why we have taken this value 03. So this value we will load in R2. So this is R2 register. Currently here we have 00. So we will execute this instruction. So now in R2 we have 03. Now move A, @R0. This instruction will bring first number in A, and our first number is A3. So see, this is A register accumulator. Here right now the value is 00. So here A3 will come now. So we will execute this instruction and we find this. Now here we will find it is A3. This value is there. Now the next instruction is move @R1, A. Now the content of A will be stored at address 40H. So at 40H right now we have 00. So here A3 will be stored, which is in A register. So we execute this. So you find A3 has been stored at 40H. Now INC R0, it will increase the content of R0 by 1. So in R0 we have 31 and it will be increased by 1 now. So now it has become 31. Now next INC R1, it will increase the content of R1 by 1. It will become now 41. So now it is 41. DJNZ R2, it will decrease the value of R2 by 1. In R2 we have 03, it will be decreased by 1, it will become 02. And since it is non-zero value, that's why program sequence will go back to this label back. This is back. So program, this sequence will come back to back. So see this. R2 has been reduced and this green this shade, green line indicates that this instruction is going to be executed. So now our program counter has come to this back label. Now again move a comma at the rate r0. So with this, the second value, which is CF, will be stored in A. So in A right now we have first data, that is A3. So here CF will be stored now. Now see this. CF has been stored. Now next instruction, move at the rate r1 comma a. This will bring the value CF at address 41. So this is the 41 address. Right now here it is 0. So here now CF will come. Now this. So CF has been stored at 41. Then INC R0. So this green line always indicates that this instruction is going to be executed. INC R0. It will increase the value of R0 by 1. So R0 will become now 32. So now this is 32. Then INC R1. It will increase the value of R1 by 1. So R1 right now it is 41. So it will become now 42. This is the destination address of our third data. 42. Then DJNZ R2. R2 will again decrease by 0 by 1. If it is not 0, then again program sequence will go to the label back here back. So right now R2 is 02, and with this instruction it will become 01 now. Now it is 01. And program sequence again sent back to label back. Now move a comma r0. Now third data will come in register A. Our third data is 29. So in A right now we are having our second data CF. So here now third data 29 will come. It's now 29. Now in next instruction, move at the rate r1 comma a. So this data which is in A register, it will be stored at address 42. This is a 42 address. Currently here we have now 00. So here data will be stored. Now it is 29. So now all the three numbers have been transferred, and this instruction INC R0, it will increase the value of R0 by 1. Now it is 33. INC R1, it will increase the value of R1 by 1. It will become 43. DJNZ R2, it will reduce the value of R2 by 1. So currently the value of R2 is 1. When we will decrease it by 1, then it will become 00. And once it will become 00, then program sequence will not jump to label back. It will come out from the loop and it will come to this sjump instruction. So we will see this. Now R2 has become 0. Due to this green shaded line will not go to the label back. It has come out from the loop, and this indicates that green line, now sjump instruction is going to be executed. So in this way, three numbers which were stored at 30H, 31H and 32H, these numbers are transferred to 30H data A3 has been transferred to 40H location. 31H data, that is CF, has been transferred to 41H location, and 32H data, that is 29, has been transferred to 42H location.